Okay, we're still in section 3.4, and we're still talking about velocity, or excuse me, motion in a straight line. So we know that we need a position function, and then the velocity is the derivative of that position function, and the acceleration is the derivative of that velocity function, etc. Okay, so in this example now, the figure to the left shows a dynamite blast blowing a heavy rock straight up in the air. And it's given in a launch velocity of 160 feet per second, which by the way is about 109 miles per hour. It reaches a height of s of t. So again, we have to be given or be able to, from physics or whatever, derive, so for you guys, given the position function at any time t. So s of t is the position of this rock that is blasted with dynamite straight up into the air. So s-axis, again, I'm using as this kind of, is the y-axis, but it's just the position, the motion of the rock will be along this. Notice what will happen is the rock will be blasted up into the air, and then once it reaches a certain height, it can't be, there's no more force to make it go up anymore because gravity's trying to pull it back down. It reaches a maximum height and then falls back down to Earth. So in simplified terms, as long as there's no wind, et cetera, it's going to go straight up and straight down. Okay, so that's motion in a straight line. All right, so part A, how high does the rock go? In other words, I'm trying to figure out what is the maximum value of the height here. So I'm setting s equals 0 to be the ground now. So up is a positive. Up is a positive position motion, and it's also a positive velocity if I'm going that way. When I start to fall back down, now I'm decreasing my position back down to 0, and my velocity then will have to be negative to come back down, okay? But the first question is, how high does the rock go, which is S max. So what happens when the rock is up here at its highest point? Notice that the velocity has to become 0 instantaneously, so that means the velocity has to become 0. Now what's the velocity? The velocity is the derivative of position, s of t, so the derivative of this guy is 160 minus 32t. So 160 minus 32t is velocity. Set that equal to 0, solve for t, and I see that that's 5 seconds. At 5 seconds, after 5 seconds, this rock gets blasted up, it comes to a stop, and then starts to fall back to Earth. So the velocity is 0 there, which tells me that it happens 5 seconds later. So to know what the position is at 5 seconds, I just take s of 5. I plug 5 seconds into my position function, which again was this guy. So it's 160 times 5 minus 16 times 5 squared. Simplify that, it goes up 400 feet. That's my maximum height that the rock will go. Part B, what are the velocity and speed of the rock when it is 256 feet above the ground on the way up, on the way down? So notice I get up here, the rock gets 256 feet up. There it is at one point. It goes up there to its maximum height of 400 and then falls back down. So it's going to be at 256 feet of height 2 different times. So I want the velocity and speed of the rock when it's 256 feet above the ground on the way down. So I actually need to know what time is it 256 feet up or on the way down. So that means I need to know when is its position 256. So I set the position function equal to 256 and then solve for t. So notice that that's a quadratic function, so I can subtract 256 from both sides. Simplify that if I want by pulling out a minus 16, because each one of these is divisible by 16. So minus 16 gives me, factored out, gives me minus 16 times t squared minus 10t plus 16. Now I have this simple quadratic. Oh, that one's actually very simple because it's factorable. We don't need to use the quadratic formula. I factor it into minus 16 times t minus 2 times t minus 8. That means that t equals 2 and at t equals 8. Those are the 2 times. 2 seconds after it blasts off, it's going to be going up past 256. And it comes up here at t equals 5 seconds. It stops and falls back down. And at t equals 8 seconds, it'll be back there at 256. So on the way up, I'm at t equals 2. So what's my velocity at time t equals 2? I already have my velocity function from part A. I just plug in 2, and I get 96 feet per second. So the speed is 96 feet per second. And on the way down, my velocity now I know is going to have to be negative. I just plug in 8 into my velocity function. And I see that it's minus 96 feet per second, which means it's falling. That negative sign just means it's falling back down towards s equals 0. S is decreasing. The position is decreasing. But the speed, again, is just the absolute value. So the speed, whether it's going up or whether it's on its way back down, is the same, 96 feet per second. All right, what is the acceleration of the rocket at any time t during its flight? Acceleration, that's the derivative of velocity. So the derivative of velocity, or the second derivative position, just to remind you. So I go back to my velocity function. The derivative of this is simple. Derivative of 160, 0. Derivative of minus 32t is minus 32. So the acceleration is minus 32 feet per second squared, which makes sense because that's our gravitational constant. Okay, and then when does the rock hit the ground again? In other words, when is the position equal to 0, right? When does a position hit? Certainly this solves, you get t equals 0 here, makes that the case. Well, that's when it takes off. But when it hits the ground again, I got to solve it for another value of t, because that's a quadratic also. So simple factor that, factor out 16t, and I get 16t times 10 minus t. Set that equal to 0, t equals 0, that's when it takes off, and then t equals 10 is when it hits the ground again.